Okay, well, let's say you have something that you normally plug into the house, but you want to bring it to the car. The car, remember, has a battery, so if it has a battery, it's using a DC current, or DC circuit. So, to access that electricity, you need to get a device that will change that. So you need to get an AC-DC converter. So you can operate a battery run device on AC instead of batteries. Or you can operate an AC device on batteries. The current in your home, remember, is AC. Current in a battery-operated device is DC. With an AC-DC converter, you can operate a battery run device on AC instead of batteries, which is obviously great if you're looking to not buy a million batteries. A converter uses a transformer to lower the voltage and a diode, which is an electronic device that allows electron flow in only one direction. All right, so a transformer, you know what a transformer is. It's the brick to your phone charger. That's a transformer. It's a whole bunch of thin wires wrapped around coils, and it transforms the electricity to lower the voltage. Since alternating current vibrates in two directions, only half of each cycle will pass through a diode. So if we imagine this silver thing to be a diode and the electricity goes back and forth, the diode limits the electricity from coming backwards, so it only goes forward. So rather than going back and forth, alternating current, the transformer is going to limit this backward motion. So now it can only go forward. Once it passes through, it can only continue to go forward. The output is a rough DC, off half of the time. Right? Because if you have one charge going like this, normally you would have another going like this and moving along, but if it's supposed to go backwards and another one's taking its place and it's not going backwards, then you have this small little gap there. To maintain continuous current while smoothing the bumps, a capacitor is used. A capacitor acts as a storage reservoir for charge. Just as it takes time to raise or lower the water level in a reservoir, it takes time to add or remove electrons from the capacitor. Capacitor therefore produces a retarding effect on changes in current flow and smooths the pulsed impulse. So you have this back and forth being limited. Let's say my head is the diode. The charge can't go backwards anymore. It can only go in one direction. And then once it goes in one direction, now my head is the capacitor, it's going to go in the capacitor. The capacitor is going to hold on to some charge until it fills up with charge, and then it's slowly going to release some, and as it slowly releases a continuous flow of charge, it's being built up by more and more charges coming in. When input to a diode is AC, output is pulsating DC. Charging and discharging of a capacitor provides continuous and smoother current. In practice, a pair of diodes is used so there are no gaps in current output. So you would use another diode to smooth it out a little bit more. So, concept check. How can you operate a battery run device on AC? Think about, research. How does it work in the opposite direction? How does a DC to AC converter work?